Hi, this is question number 98 on stoichiometry. What mass of Na2CO3 is produced when 1.02 moles of NaOH reacts with 1 mole of CO2? So that means this is 1.02 here and this is 1. What mass of Na2CO3 will be produced? If we're to write out the molar mass of this Na2CO3, when you calculate it stepwisely, you get about 106 grams per mole. Okay, I'm just going to keep that aside first. Now I want to try something here. If this is 1 mole, right, and I compare this to, I can see that 1 mole of this produces 1 mole of Na2CO3. So that means that the number of moles of Na2CO3 produced should be 1 mole. Number of moles of Na2CO3 is 1 mole. And that would mean that the mass of Na2CO3 will then be number of moles times molar mass. So that would be 106 grams. So that is one answer. If I had used this 1.02 moles that was given, and then I compared the NaOH with the Na2CO3 this time around, this is like a different thing now. I would say 2 moles of NaOH produces 1 mole of Na2CO3. Therefore, the 1.02 moles of NaOH I had would mean that what we produce here would be 1.02 divided by 2, which is about 0.51 moles. So that stands as the number of moles of Na2CO3. From there, you can get your mass. That's just number of moles times molar mass, right? So 0.51 multiplied by 106. If you do that, you have about 54.06 grams. So there are like two answers here. The first one is 106 grams, and then the other method I'm getting 54.06 grams. So which is right and which is wrong? Because I mean, one must be right and one must be wrong. So how do we know? Well, this first method is wrong and the second method is right. So this is because I'm meant to compare the limiting reagent with my product. Okay, that is what is meant to happen. Now, judging by the moles here, 1.02 and 1, it's like the 1 is smaller, 1 mole is smaller. Yeah, but we don't just judge by the moles like that. We actually get the limiting reagent after we have divided this moles by this number here, so you know the rate at which that species is reducing. That's why we're doing that division. So 1.02 divided by 2 will give you 0.51, whereas 1 divided by 1 in front of the CO2 here will give you just 1. So if you have to compare 0.51 and 1, you'll notice that the 0.51 is a smaller rate, right? That's the ratio we've been talking about. So that means the 0.51 is a smaller one, which means that is the limiting reagent, okay? It's going to get used up first, okay? So that's it. Maybe we should not call it rate, but it seems as though it would last longer that way. But anyway, you get the point. The smaller ratio there is your limiting reagent. So that would mean that the NaOH is the limiting reagent, and I must compare this and this. See that? This. Alright, so if this was helpful to you, leave a like. Do not make the mistake of getting 106 as your answer. That would be really wrong. And I'll see you on 99. Question 99 is a very wonderful question. So please turn on the notifications or follow this page if you have not, so that you would see it. Alright? So I'll see you on 99. Bye bye.